Hello everyone, welcome to Nrcm, and today I'm going to discuss about operating system, unit 1, distributed systems and parallel systems. So let's see the architecture of distributed operating system. So normally distributed systems use multiple central processors to serve multiple real-time applications and multiple users. Here data processing jobs are distributed among the processors accordingly. So we can say like the processors or the process communicate with one another through various communication lines. The lines may be like high speed buses or telephone lines, and we can call these distributed systems as, or they are referred as loosely coupled systems. Normally distributed systems, they work on distributed memory. Processors in a distributed system may vary in size and function. These processors are referred as sites, nodes, computers, and so on. Like as you can see the diagram, so there are different types of systems which are connected to the common communication network. So I hope you can see. So this is first, and this is second, and this is third, fourth, and fifth. So yeah, there are totally 5 computers, and we can call them as like sites, nodes, computers, and so on. So these 5 systems or nodes, they are connected to the common network that is called as communication network. So they can share the messages, they can pass the messages via this communication network. The main advantage of these distributed systems are like first thing is resource sharing facility is available. The user at one site may be able to use the resources available at the another site. And second advantage is like speed up the exchange of data with one another via electronic mails. And third comes is like they will provide this distributed like system, it will provide the better services to the customers. And also it reduces the load on the host computer, and it reduces the delays in the data processing as well. And one more main advantage is like if one site fails, like if one of the node fails in the distributed system, the remaining sites can continue operating without any effect. So that is a major advantage of these distributed systems. And coming to the like types of distributed systems, we are having two types. First one is client server and second one is peer-to-peer system. So what is the meaning of client server? So as the name itself indicate, like client is to request a resource and server gives the requested resource. Client is for requesting some resource or server responds to that request. So here when the client connects to a server, the server may serve multiple clients at the same time also. I mean like single client and single server will not be available. So one client can connect to the server at a time, but the server can provide the services to different clients at the same time. And this client server system are also referred to as tightly coupled operating system. Like we can say like it is like multi-processors and multi-computer environment also. Like client server systems, they function as a centralized server because they approve all the requests issued by the client systems. And the next type of distributed system is like peer-to-peer system. Here what happens, the nodes will play an important role in the system. The nodes are nothing but the systems like 1, 2, 3, 4. They play the important role in this peer-to-peer system. Here what happens, the task will be evenly distributed among the nodes. The work will be distributed in even model. Like these nodes can share the data and resources as they need. And but to communicate with each other node, they require the network to connect with them. And this peer-to-peer system, it is known as loosely coupled system. This peer-to-peer concept, it is used in like computer network applications since they contain a large number of processors that do not share memory or clocks. There we can use this peer-to-peer system. Here and each processor has its own local memory and they interact with one another via a variety of communication methods like telephone lines or any other high-speed buses also. So the communication lines can be like the network, telephone lines or any of the high-speed buses. So this is all about the distributed systems. Now we are going to discuss about parallel systems. I hope you all understood what is distributed systems. Now we are going to discuss about parallel systems. So here comes a diagram of parallel systems. In general, normally systems are there in single processor systems. We know that like we are using the systems of with single processors. Means what is the meaning of single processor system? Like they have only one main CPU, only one CPU will be present. And but coming to this multiprocessor systems, they have more than one processor in the CPU. This multiprocessing operating system or these parallel systems, they support the use of more than one processor in a close communication. So why they support is like because of this multiple calculations are performed simultaneously. The system that support parallel computing can have shared memory or distributed memory. What happens in shared memory? All the processors share the common memory. Coming to the distributed memory, memory is divided among the processors. It is the use of multiple processing elements simultaneously for solving any kind of problem. So here what happens? The problems are broken down into different instructions and they are solved concurrently as each resource that has been applied to work is working at the same time. Means the problem will be divided. So if this is a one main problem, the problem will be divided into subtasks. So one subtask will be given to process 1, process 2, processor 3, processor n, go on. So and they all will share the shared memory or distributed memory. And here we have bit level parallelism also. The bit level parallelism is like it is a parallel computing which is based on the increasing processor size and it reduces the number of instructions that the system must execute in order to perform the task on a large sized data. And next, like we can take an example where 8-bit processor must compute the sum of two 16-bit integers. The 8-bit processor, I am repeating, must compute the sum of two 16-bit integers. It must first sum up the 8 lower order bits and then add the 8 higher order bits, thus requiring two instructions to perform the operation. A 16-bit processor can perform the operation with just one instruction. So this is bit level parallelism. Next we have like instruction level parallelism. Here a processor can have only one address, less than one instruction for each clock cycle phase. These instructions can be reordered and grouped, which are later on executed concurrently without affecting the result of the program. Next we have like task parallelism. Task parallelism, like it employs the decomposition of a task into subtasks and then allocating each of the subtasks for execution. Like the task will be divided into subtasks and each of the subtasks will be executed. And what are the advantages for this multiprocessing? First one is it will increase the throughput. Why the throughput will be increased is like it increases the number of processors, so more work can be completed in a unit of time. The big task can be completed within the same unit of the time because the task is divided into small subtasks. And obviously it is second advantage might be it is cost saving. Why? Because they share, these parallel systems, they share the memory, buses, peripherals, everything, because if they are using the shared memory, so everything can be shared, so which saves the money as compared to the like multiple single systems. And one more is like if any number of the programs, different programs have to operate on the same data, it is cheaper because if they are operating on the same data, they can use the same memory, shared memory, store the data on a single disk and share by all the processors instead of using many copies of same data. Next, third, like we can say it increases the reliability. So here what happens as the workload is mainly it is distributed among several processors like process 1, processor 2, the workload is being distributed. So the result is in increased reliability. If suppose if consider if any one of the processor is failed, like process 1 or processor 2, any of the processor is failed, like the work might be slowed down. Okay, it might slightly slow down the speed of the system. I mean the work in progress might be slightly down, but the system will work smoothly only. It will not affect the any other processes. So that also comes under the advantage itself. So yes, this is the, I hope you all understood, and we have discussed about distributed system and well as parallel systems. Thank you.